Okay, we're going to talk about chapter 0.7, which is complex numbers. So our objective here is to perform operations with complex numbers. Complex numbers are another set of number system. They consist of a real and an imaginary part. Okay, and they're always in the form a plus bi. So here I have my real part, and here I have my imaginary part. Now, every number that we've talked about so far, we've only been really dealing with the real numbers, but any number such as 4 can be written as this complex number. I have 0 imaginary parts, so I can just write plus 0i. So 4 plus 0i is a complex number, but this 0i is unnecessary. Okay, so we have our complex number system. Okay, and that complex number system is split into two. We've got the real, and we've got the imaginary. Okay, and then we've worked down through the real with the rational and irrational and so forth and so on. Okay, but now we're talking up here about this large group of numbers. Okay, and we can do operations such as add, subtract, multiply, divide, and that's what we're going to look at today. Okay, so the imaginary unit. The imaginary unit, the one thing that you really need to know is that I equals the square root of -1. Okay? And that's where we get our imaginary number from. Now, these rests are simply created from this fact right here, that I equals the square root of -1. Okay, well, if I square this I, okay, I get I squared. And if I take the square root of -1 squared, I get I squared equals -1. When I go down further here, we're just going to create these. Well, I to the third is the same thing as I squared times I. Okay, well, if we look over here now, I squared was just -1. And then I have I. Well, -1 times I is -I. I to the fourth, we can say I squared. I squared. Well, I squared, we look up here and we got -1. So that's -1 times -1, which is 1. After this, we can just keep repeating. So I to the fifth will be I to the fourth times I. Well, I to the fourth, we said is 1 by 1 times I, which is I, which is what we had at the top. I to the sixth would be I to the fourth, I squared, which is 1 times -1, which is -1, which is I squared. If you notice here, this pattern is going to continue. We can always pull out or take out an I to the fourth, and we're left with whatever here. Okay. So I want you to write something else on these too while we're here. Okay, we're going to say this is R1, this is R2, R3, you said it right, R0. Okay, and we'll come back to that a little bit later. Okay, but what we write, or when we reduce, we write I, -1, -I, and 1. Okay, our I here can never have a power bigger than 1. Okay, I can't have a square, I can't have a 6, I can only have a power of 1 right there. Alright, so if we simplify here, anytime you see a negative under an even root, an even index here, okay, you're going to change that to a positive and you're going to bring out the I in front. You're not going to change the sign out here in front. Okay, you're just going to take this negative out and put an I. So you have I radical 9. Well, what's the square root of 9? Well, that would be 3 plus, or in addition to your I that's out front. Okay, so that's one way we can look at this. Another way is if I have 8 here, negative 8, we can say that is the square root of negative 1 times 8. Well, what's the square root of negative 1? That would be I. We just talked about that. And the square root of 8 now, we break apart. That's 2 and 4, 2 and 2. So I got a pair of 2's that's coming out front with the I. So I have 2I, and I had the 2 left underneath. So 2I radical 2. Now, when performing some more basic operations here, okay, let's look at this addition and subtraction here. When performing operations with complex numbers, treat them like binomials with variables. Okay, with variables. This I is no different than if I were to make that an X. And then at the end I would say X equals the square root of negative 1. Okay. It's the same thing there. So let's get rid of parentheses. If I distribute the plus, nothing changes. So I have 3 minus 2I minus 1 plus I. Okay, and then I go combine like terms. That's 3 minus 1 is 2. Negative 2I plus I is minus I. So I get 2 minus I. With subtraction, however, when I distribute that negative, it changes the signs of both of these. So you have 2 minus I minus 3 plus 4I. Now combine like terms. You get 2 minus 3. That's negative 1. You get negative I plus 4I. That's plus 3I. And that's our addition and subtraction. Just make sure that you change the sign in parentheses. Okay. Now multiplication. Let's start with this easy one here on the right. Okay. Again, treat this like if they were x's. It's no different. So we'll distribute. So I have I times negative 3, negative 3I. I have I times I, which is plus I squared. Now earlier, if we look back at our table here, we saw that the I squared here is negative 1. So instead of writing I squared, I'm going to get rid of that. And I'm going to write minus 1. So then I have negative 3I minus 1. But this is not in our standard form, the right form. So I'll say negative 1 minus 3I. It has to be an A plus BI form. And over here, okay, again, we're still just distributing, okay, but I got to distribute everything. So I'll take my first, 3 times 2 and get 6. My outside, 3 times I, 3I. My inside, negative I times 2, that's negative 2I. And my outside, that's negative I times I, minus I squared. Again, instead of writing I squared, that's negative 1. But I had this minus here. So that is minus I squared. So minus a negative 1 will become a plus 1. So combining like terms, I'll get 6 plus 1 is 7. And 3I minus 2I is I. So I've got it. Remember, combine like terms on addition and subtraction, distribute, and reduce your i's there. Remember, we can't have radicals in the denominator, okay? And I is the square root of minus 1. Okay, so I is a radical. So we can't have an I in the denominator because we can't have a radical in the denominator. So in order to get rid of that, okay, when it is a binomial, we multiply by the conjugate, which is just changing that middle sign. Remember, this makes it a a difference of squares here. And again, just like the last slide, we distribute all this out. First outside, inside, last. FOIL. Outside, inside, last. So I'll take here 2 times 1. You get 2. 2 times negative 3i, it's minus 6i. Negative I times 1, that's minus I. Negative I times negative 3i, that's plus 3i squared. In the bottom, I have 1 times 1, 1. 1 times minus 3i, that's minus 3i. 3i times 1, that's plus 3i. That's 3i times negative 3i is negative 9i squared. Just like before, instead of writing negative I, instead of writing I squared, we cancel this out and write minus 3, because I squared is negative 1. And instead of negative 9i squared, we now have a plus 9. So when we simplify this here, we will get 2 minus 3 minus 1. Negative 6i minus 1i is minus 7i over, well, these two cancel each other out. So I have 1 plus 9 is 10. Now here, this is only one term. And remember, I need it in a plus bi form. Okay, so I got to split this into my a and my b. So I'm going to take negative 1 over 10 minus 7 over 10 I. This would be your completed answer. Now I don't always multiply by the conjugate here. Okay, if it were something like this, say 12 over 2i. Now let's change that because I can reduce that already. Let's say 11 over 2i. See how this is only one term and this was 2 terms? If it is one term, all I have to do is multiply by I on top and the bottom. Then I get 11i over 2i squared. Well, what is I squared? I squared is simply negative 1. So on the top I get 11i, and on the bottom I get negative 2. Okay. So know the difference in when do I multiply by the conjugate and when do I multiply by just I. Okay, simplify. So we said that I can't have I to any other power than 1. Okay, so if we look back at this chart here that we had at the beginning, okay, I, negative 1, negative I, and 1. The easiest number here to deal with is 1, which is I to the 4th. So I'm going to try to get everything as I to the 4th. Okay, so if I look at I to the 7th, that becomes I to the 4th, I to the 3rd. Well, I to the 4th is 1. And when I multiply anything by 1, it doesn't change. So this I to the 3rd is not changing with this 1. Well, and I to the 3rd was negative I. So in this case, I to the 7th is the same thing as negative I. If we do 13, that's I4, I to the 4th, I to the 4th, I. That's 4, 8, 12, and 13. Remember, I to the 4th are 1, so 1 times 1 times 1 times I is I. So I to the 13th is the same thing as I. Well, that doesn't really help me on big numbers like this. I don't want to write I to the 4th out that many times. So how are we going to do this? Well, we're going to divide the exponent by 4. Why 4? Well, there are 4 options. My 4 options are I, negative 1, negative I, and 1. Okay, 4 options. And then we're going to look at the remainder. Okay. Now I had you write those remainders down back here. R1, R2, R3, R0. remainder of 0. So if we do R1, R2, R3, R0, okay? So if I take this 100, I take 100 divided by 4. That goes in 25 with remainder of 0. There's nothing left over. Well, if I look over here and see where my remainder 0 says, that is 1. Well, think about it. This tells me that I can have 25 groups of 4. So that's 25i to the 4th, which are all 1, and nothing left over. So if I have all I to the 4th, then I just have 1. What about something like I to the 383? All right, we'll take 383 divided by 4. So 4 goes into 38, 9 times, that's 36. Subtract, we get 2. Bring down my 3. 4 goes into 23, 5 times, that's 20 with 3 left over. So I have a remainder of 3. Remainder of 3 goes with I to the 3rd, which is negative I. So I to the 383rd is negative I. So just divide by 4 and look at your remainder right here. This part right here is important. Okay, 2 minus I quantity to the 3rd. What does this 3 tell me to do? I do not distribute an exponent. Okay, I can't distribute that in there. This 3 by definition tells me to take this times itself 3 times. Well, if we cover this up and work here, I just FOIL this like we did earlier. So I've got 2 times 2, that's 4. 2 times minus I, that's negative 2I. Negative I times 2, that's negative 2I. I have negative I times negative I, that's plus I squared. And I still have the 2 minus I in front. Well, I squared hasn't changed anything. It's still minus 1. So we bring down the 2 minus I. I have 4 minus 1. That's 3. I have negative 2I minus 2I. That's minus 4I. Well, again, I just FOIL this out. Distribute it all out. 2 times 3 is 6. 2 times minus 4 is minus 8I. Negative I times 3 is negative 3I. Negative I times negative 4I is plus 4I squared. Well, I squared is minus 1, so instead of writing plus 4I squared, that becomes a minus 4. So I have 6 minus 4 is 2. Negative 8I minus 3I minus 11I. There's our answer. We are in A plus BI form, so we are done. That concludes complex numbers. So we've got our suggested problems here, the 0.7, page 79. We'll have our quiz the next day in class, and we also have a test coming up, chapter 0 test. Okay, within the next couple days. So make sure you're looking at all chapter 0, and I put up a review on the website. Okay, so if you got any questions, make sure you're getting in before or after school and asking me. Thanks for watching.